Welcome to my channel Circuits Analytica. In this video, we will discuss the operation of a monostable multivibrator using bipolar junction transistors. A monostable multivibrator is a circuit which generates pulse for a small duration after the application of a trigger signal. There are two transistors Q1 and Q2. Collector of transistor Q1 is coupled to the base of transistor Q2 through capacitor C, and collector of transistor Q2 is coupled to the base of transistor Q1 through a potential divider network which consists of resistors R1 and R2. In a monostable multivibrator, there is a stable state given as Q1 off and Q2 on, and a quasi-stable state given as Q1 on and Q2 off. So this is the diagram of a monostable multivibrator. There are two transistors Q1 and Q2. Collector of transistor Q1 is coupled to the base of transistor Q2 through a resistance capacitance network, and collector of transistor Q2 is coupled to the base of transistor Q1 through a voltage divider network which consists of R1 and R2. As one of the two ends of resistor R2 is connected to minus VEE, potential at the base of transistor Q1 is negative and transistor Q1 is in the off condition. As transistor Q1 is in the off condition, collector voltage of transistor Q1 is equal to plus VCC, and so transistor Q2 is in the on condition. And this is the stable state of the monostable multivibrator. Initially, multivibrator is in stable state. Q1 is off and Q2 is on. Circuit will remain in this state as long as the application of a trigger pulse. As Q1 is off, its collector voltage is plus VCC, which is coupled to the base of transistor Q2, which will keep the base emitter junction of transistor Q2 in the forward biased condition, and so transistor Q2 will be on. As Q2 is on, its collector voltage is 0.2 volt, which is not sufficient to make the base emitter junction of transistor Q1 forward biased. In fact, base emitter junction of transistor Q1 is reverse biased, and so transistor Q1 is in the off condition. So this is the diagram of the monostable multivibrator during stable state. Transistor Q1 is off, so collector voltage is equal to plus VCC. As collector voltage of transistor Q1 is equal to plus VCC, transistor Q2 is on. As transistor Q2 is on, its collector voltage is equal to 0.2 volt, and because of minus VEE, base of transistor Q1 is existing at a negative voltage, so transistor Q1 remains in the off condition. When a negative trigger pulse is applied to the base of on transistor Q2, when base of on transistor Q2 is pulled down for a very small duration, transistor Q2's base emitter junction is reverse biased, so transistor Q2 is turned off. As transistor Q2 is turned off, its collector voltage rises from 0.2 to plus VCC, and as collector voltage of transistor Q2 is at plus VCC, base emitter junction voltage of transistor Q1 becomes positive greater than 0.7 volt. So transistor Q1 is turned on. As transistor Q1 is turned on, its collector voltage drops from VCC to 0.2 volt, and as transistor Q1's collector voltage dropped from VCC to 0.2 volt, the base emitter junction of transistor Q2 remains in the reverse biased condition. So transistor Q2 continues to be in the off condition, and the monostable multivibrator is in the quasi-stable state of operation. So this is the quasi-stable state of the monostable multivibrator. Q1 is on and Q2 is off. The base emitter junction voltage of Q2 is the sum of voltage across capacitor Vc and voltage between collector and emitter of transistor Q1 Vc1. So VBE2 is equal to Vc plus VCE1. Capacitor C charges towards voltage VCC. Whenever capacitor voltage Vc becomes equal to 0.5 volt, base emitter junction voltage of transistor Q2 becomes 0.7, 0.5 plus VCE1, which is equal to 0.2 volt. That means whenever capacitor voltage Vc becomes 0.5 volt, transistor Q2 is turned on and VCE2 drops from VCC to 0.2 volt, forcing transistor Q1 to be turned off. So this is the pictorial representation of the same. So transistor Q1 is on, Q2 is off. As transistor Q1 is on, its collector voltage is equal to 0.2 volt. As transistor Q2 is off, its collector voltage is equal to VCC. Capacitor is getting charged. As current flows through capacitance C, as shown in the diagram, from VCC to collector of transistor Q1. Initially, voltage across the capacitor is equal to 0 volt. Capacitance is getting charged. Capacitance voltage is equal to 0.1 volt. The base emitter junction of transistor Q2 is not forward biased, as the voltage between base and emitter is just 0.1 across the capacitance and 0.2 volt between collector and emitter of transistor Q1. 0.3 volt is the value of VBE2. So VBE2 is less than 0.7 volt. Transistor Q2 continues to be in the off condition. Now capacitance voltage is equal to 0.2 volt. So now total voltage between base and emitter of transistor Q2 is equal to 0.4 volt. So still the voltage is not sufficient to turn on transistor Q2. Transistor Q2 continues to be in the off condition and transistor Q1 continues to be in the on condition. Capacitance voltage rises from 0.2 to 0.3 volt. So this time voltage between base and emitter of transistor Q2 is equal to 0.3 volt across the capacitance plus 0.2 volt between collector and emitter of transistor Q1. Capacitor continues to charge and now capacitance voltage is equal to 0.4 volt. Now as capacitance voltage is equal to 0.4 volt, total voltage between base and emitter of transistor Q2 is equal to 0.4 across the capacitance plus 0.2 between collector and emitter of the on transistor Q1. So total voltage is equal to 0.6, which is not sufficient to forward bias the base emitter junction of transistor Q2. Transistor Q2 continues to be in the off condition. Capacitor C continues to charge. So capacitance voltage becomes 0.5 volt. Whenever capacitance voltage becomes 0.5 volt, total voltage between base and emitter of transistor Q2 is equal to 0.5 volt across the capacitance plus 0.2 volt across the on transistor Q1 VCE1. So transistor Q2 is turned on. As transistor Q2 is turned on, its collector voltage drops from VCC to 0.2 volt. And now as collector voltage of transistor Q2 is dropped from VCC to 0.2 volt, base potential of transistor Q1 becomes negative. So transistor Q1 is turned off. As transistor Q1 is turned off, collector voltage of transistor Q1 rises from 0.2 to VCC. So transistor Q1 is turned off, collector voltage of transistor Q1 is equal to VCC, which is sufficient to keep the base emitter junction of transistor Q2 in the forward biased condition. Transistor Q2 remains in the on condition, and we can say that the circuit returned back to the stable state. And the circuit remains in this state as long as a negative pulse is applied to the base of the on transistor Q2. Thanks for watching Circuits Analytica. Enjoy learning.